Okay, coming to numerical differentiation. How do I do numerical differentiation? It is not the differentiation of the polynomial that we get after interpolation. We should do the formula itself because polynomial is an approximation to the given data. Instead, formula is a standard one. So we go with the formula only, not the polynomial approximation. Okay, now coming to Newton forward formula. This is the Newton forward formula, as we all of us know, y naught plus p into delta y naught and all those things, right? Where p is equal to x minus x naught by h for forward. So how do I do differentiation is dy by dx if I consider, I can clearly see y is in terms of p. So I'll just rewrite it by chain rule kind dp by dx. What would be dp by dx from this? I can clearly see x naught is a constant, h is a constant. So dx by d by dx of x would be 1. So I'll be having 1 by h. So I'll be having something like 1 by h into derivative of the dy by dt. This y I should be differentiating with respect to p. Just see here, y naught is a constant. So derivative of constant with any variable would be 0. P derivative is 1. So I have delta y naught. Here it is p square minus p. So derivative would be 2p minus 1 by 2 factorial delta squared y naught plus this one would give me what? P square, p cube minus 3p square plus 2. Okay. So it would be what? 3p square minus 6p plus 2 by 3 factorial delta cube y naught. And so on. It goes on and on. So what you will do, will just multiply with 1 by h and take the derivative. Suppose if I am asked to find d square y by dx squared, guys. So what do I do? D by dx of dy by dx. Clearly you can see dy by dx is again in terms of a p only. So what do? I'll rewrite this as d by dp into dy by dx into dp by dx. Why you are writing like this? I can just cancel out this 2 and then again I have d by dx off only. But then when I don't cancel out, it has a different meaning. It's a derivative of dy by dx with respect to p, and this is dp by dx. So already I have a 1 by h. So dp by dx for the second time would contribute for one more 1 by h. So I'll be having 1 by h squared. Now again derivative of this delta y naught is 0. Now 2p minus 1 would give me what? 2 by 2 factorial delta squared y naught plus this would give me what? 6p minus 6 by 3 factorial delta cube y naught and so on. I'll do for the fourth differences as well. Of course, this is nothing but 1 by h squared delta squared y naught plus, of course, 3 factorial is 6. So it is p minus 1 into delta cube y naught plus and so on. Okay. There's one small thing that you need to observe here. Suppose if I'm being asked, just see here. If I'll write here the next slide. If I'm being asked dy by dx at x is equal to x naught. Just see here, guys. What would be p? P is x minus x naught by h. Na? X is what? X naught only. So x naught minus x naught by h, p value would be 0, guys. Dy by dx at x is equal to x naught if I'm being asked. P would be 0. So you'll observe here, just see here, if P is 0, this term vanishes. This term vanishes. These two terms vanish. Like that, the things will be. I'll just write the formula. There'll be rhythm in it. Just observe. 1 by h into delta y naught is there, right? Delta y naught is there. So what happens is, just see here. Also, I'm sorry. Yeah. P is 0. So here in this formula, delta y naught is there without P. So delta y naught comes minus 1 by 2 delta squared y naught plus 1 by 3 delta cube y naught minus 1 by 4 delta power 4 y naught, and it goes on and on. The formula goes on and on. Okay. You can as well check the same thing for d square y by dx squared, guys. If you check that it is asked at the initial value, you can use this formula and easily do. Okay. At x is equal to x naught. See here, 1 by h squared. Wherever p is there, it goes to 0. Delta squared y naught, there is no p in this formula. Wherever p is there, it is 0. So minus delta cube y naught, and it goes on and on. Okay, you can check for the next terms as well. I'll just show the Newton backward formula as well in this video itself. Newton backward differentiation formula. Because I put the heading numerical differentiation, I am discussing. Okay, how will be my Newton backward formula? Let us see. Y of x, this is equal to yn plus del squared. I'm sorry, p into, right? P into del square, p into del yn, p into del yn plus backward formula has p plus 1, na? P into p plus 1 by 2 factorial del squared yn plus p into p plus 1, p plus 2 by 3 factorial del cube yn. Okay, and it goes on and on, right? Yeah. So backward formula is like this. Now, what is p here that you have to remember, please? This small change. It is x minus xn by h. Okay. Now, again, I'll be finding the numerical differentiation formula, right? So what I will do, same process like how I have done prior, dy by dx. Of course, I'll be having 1 by h as well, and I'll be differentiating this with respect to p. That's it. Yn would be 0. P of del yn would be del yn plus this would be 2p plus 1 by 2 factorial del squared yn plus this would be 3p squared plus there will be no minuses. That's it. That's the only difference between both the formula. That's it. Del cube yn and so on. It goes on and on. Of course, I can check for d square y by dx squared as well. It would be 1 by h squared. Delta will be replaced by del only. This also goes off. So it is like 2p by 2 del squared yn plus 6p plus 6 by 3 factorial del cube yn and so on. Okay. The same thing is repeated. I mean, similar thing is repeated for dy by dx at x is equal to xn, guys. At x is equal to xn. At x is equal to xn. Here p would be again 0. You can just observe. P is nothing but x minus xn by h. P would be 0. So what's the change? If you ask me, it's very simple. It is just 1 by h into del yn would be there. There'll be no plus minus alternating signs. All are pluses only. Half del squared yn plus 1 by 3 del cube yn and so on. It goes on and on like this. Okay. Similar thing repeats for d square y by dx square at x is equal to xn, guys. 1 by h squared. P goes to 0. Okay. So whatever p terms are there, they will go to 0. This is 2 by 2, guys. I'm sorry. So I'll be having del square yn plus del cube yn. Okay. Basically, what's the change if you ask me? Just see here. For the forward formula, there are alternative plus minus signs. For the backward formula, same formula only. Only thing is, I'll be having, of course, del will be there instead of delta. I'll be having all plus signs because backward formula has all plus signs only. Okay, this is how I will do. Do practice forward formula. I'll do a problem in the next video.